of x equals x to the 3/5 power. What is the approximation for f of negative 31.8 found by using the line tangent to the graph of f at x equals negative 32? All right, so what we're going off of is that they give us an x value to use with the slope of the tangent line. So we're trying to make a tangent line function that goes through x is negative 32. Well, they don't even give me what y is in the original function when x is negative 32. So I have to find that out by using my original function here. Simply plugging in an x, getting out a y. You could go ahead and do this on your calculator. Just make sure you put parentheses around negative 32. You could also think about what this fractional exponent means. The denominator is the root of the radical. So this is the 5th root of negative 32 cubed. And it doesn't matter which parts you do first. I obviously don't know 32 times itself 3 times in my head, but I do know that the 5th root of negative 32 is negative 2, because negative 2 times itself, 5 times 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. I just know that. And that, since it's odd, it would have to be a negative, and then take that to the 3rd power, which would be a negative 8. So I now have my point. And here it is to check it on the calculator. And then I want to take the derivative of my function. And so I'm going to bring the 3/5 power in front. And then I have to do 3/5 minus 1, which would convert into 3/5 minus 5/5, which is negative 2/5. Okay, and then I'm wanting to find the slope at that negative 32. So what's really happening here, remember, a negative exponent really sinks it to the bottom. It's up to you how you want to do it, but it's taking the 5th root of negative 32 again, which is going to be that negative 2 squared, which is 4, and it's going to get on the bottom. So that should become a 3 over 5 times 4, which is a 3/20. But let's check real quick. I would do 3/5 times negative 32 to the negative 2/5. And so we can use the decimal, or it gets that 3 over 20. Let's do decimal. So that's my m. Okay, they're going to want you to type in the tangent line, and they want it solved for y. So what we always have first is y minus my y value, so that'd be plus 8, equals my slope times x minus, so plus 32. We want to subtract the 8 over to get y by itself. So here in the answer, you're going to put y equals 0.15 times x plus 32 times negative 8. If you want to distribute and simplify, you can, but you don't have to. Then they want the approximation of 31.8 using this. And so we would do this. Negative 31.8 plus 32 is 2/10 of a difference times 0.15 minus 8, negative 7.97. So what we got? This is an answer. This is an answer. And then it says, it's just going to be drop down menus, but I put a slash here to show you both of them. When x is less than 0 or greater than 0, the second derivative f double prime of x is less than 0 greater than 0. So we're going to take this a step further and talk about the second derivative, because second derivative, remember, tells us about concavity. So I'll write my first derivative here again. It was right there. 3/5 times x to the negative 2/5 power. We're going to take it a step further. 3/5 times negative 2/5 would be negative 6/25 x to the subtract 5/5 from the power, so it'd be negative 7/5. Yuck. And you could fix it, of course, but I'm going to keep it like that for right now. And then I will make a sign chart for my second derivative. This function cannot be factored. It's just one term. It's really this. So there's no factors. All we're going to have is at 0, maybe something will change. So let's think about if I plug in a positive 1. 1 to the 7th power would be 1. 5th root of 1 is 1. So I'd have a negative 6 divided by a positive. That would give me a negative. If I plug in a negative 1 to the 7th power, that's a negative. 5th root of a negative is a negative. So that'd be negative divided by negative is positive. We want the piece where our x value is. So we were evaluating this when x is negative 32, which is obviously less than 0. So you would select that piece. If they would have said up here when x is 10, you would have chose the piece that's x is greater than 0. The second derivative, what we just found, is positive greater than 0. And what that means is it's concave up, like this, where this is concave down. So we're going to put concave up. Near the point of tangent, making the value an over or under approximation. Let's think about this. If I have a curve that is concave up, and so let's say here was my point of tangency. If I want to know at this x value, and I use it on this line of tangency, am I going to be over or under what the actual value would be on the curve? I'm going to be under it. No matter how I draw my tangent lines on a concave up function, I'm always under the function. So it's an under approximation. Whereas if it's concave down, and let's say here's my point of tangency, here's my tangent line, I want to find this value, I'm over it. I'm over top of it. So picture that in your head of a curve and drawing those tangent lines, and it'll help you know when you're going to be an over or an under estimate. So that means that we found the y to be negative 7.97, but actually it's probably a little higher than that if we had the actual function, which we do. I could even, let's do it real quick. So if I were to plug in negative 31.8 to the 3/5 power, see it's negative 7.9699, not much, but this is a little less than that. So that's why it was an under, or what did we say? Oh yeah, under approximation.